Welcome back, fellow aircraft builders and aviation enthusiasts. I wanted to give you a quick tooling update. I haven't done a lot of progress on the plane itself because I still need to repair the bending brake, and I'm working on some other fixtures. In addition, I had about a week and a half vacation. Spent some time down in the Caribbean to recharge my batteries with family, and that was a much needed break. So back to reality and back to the grind on both work and the airplane here, though. In previous videos, I talked about some welding equipment, and I also talked about my bending brake problems. So to address the bending brake problem, the idea was that I was going to drill out all the pop rivets because they were pulling apart with the heavier gauge material. I was going to replace them with solid rivets. Back in Christmas, I received some gift money and thought I'd splurge on a aircraft, professional, basically aircraft riveting gun, and did a little bit of research, talked to some folks. The consensus was that a 3X gun was going to be enough to set all of the rivets that I need to set in this aircraft. The wing spars require AN5 rivets, and if you're not familiar with AN terminology, an AN5 rivet is a 5/32, the 5 being a 5 and 5/32 diameter. AN4 would be 4/32 in diameter, or 1/8 inch. And so a 5/32 diameter rivet is a fairly heavy, robust rivet to be setting, and you need a good sized gun to do it. But got some advice, talked to a few folks, read some reviews, things like that, and determined that a 3X gun probably would do, or should be able to do the job. However, determined that not all 3X guns are created equal, and didn't know enough about them at the time to really make an informed decision. So I ended up buying this 3X red box gun from Aircraft Spruce. Perfectly acceptable rivet gun, just isn't heavy enough, doesn't hit hard enough to set AN5 rivets. So it was a disaster when I went down back to the bending brake to try to reattach the piano hinge. The 3X gun would it would swell the rivet in the hole, which it's supposed to do initially. When you tease the trigger lightly, it would swell the rivet, basically set the rivet in the hole. But then when you pull the trigger and go full tilt on it, or any variation thereof with the bucking bar to try to get the shop head to form, that's the tail of the rivet, the shop head that needs to form around it to clamp it together, no dice, just wouldn't happen. It would hit over and over and over. This would never move. And the problem is when you hit a rivet several times, it work hardens the metal. Once the rivet is work hardened, it's not going to form at all, period. You're done with it. It's not going to go anywhere. So bottom line is that particular 3X gun just doesn't hit hard enough to form these longer 5/32 rivets, or AN5 rivets. It's too late for me to send it back, so we'll see if I use it on the cabin sides. Those are AN4 rivets. It should be able to do the job on those, but we'll see. Back when I started the project, I had this grand idea that I was going to use an arbor press with a hand squeezer set, and then use the ram on the arbor press to just manually squeeze the rivet down by pulling on the lever. That turned out to be a terrible idea as well. Wasted $50 on having machine work done and about $30 on a hand squeezer die set to go with it, which is why I really hemmed and hawed about this. And it turns out this is a $200 waste of time. So what do? Well, one option that I should have considered more seriously back in the day is a C-frame. Knew about these. I've seen them in action. I don't know why I didn't elect to go this route in the first place. I thought that, my arbor press idea was going to be great. And I thought then after that didn't work out, I thought maybe the rivet gun route was just, why not bite the bullet, have a nice rivet gun to show for it. And I should have never done either of those things. What I should have done was this right from the beginning. Now I know this option is going to work, even though I don't have it finished yet. I know this is going to work. I've seen them built. I've seen them in action. I've seen people do them. Mine is actually heavier duty than any of the ones I've seen built, but that's just because I bought some scrap metal and put it together from just random cut-offs that I could find. So all it is a piece of tubing here, another piece of tubing down there. This is 2x3 inch. It's quarter wall thickness, which is really heavy gauge. That's 4x6 tubing, again quarter wall thickness, and then some 6-inch channel that I was able to get at Alro Steel's Alro Plus retail store, where they sell just random drops and cut-offs of material. This is 6 inches from top to bottom here, minus the 1/2 inch for the aluminum plate, and then the rivet set down here. So I've got a 4130 steel rod, solid steel rod is the ram, and a little aluminum rivet block here. The rivet set right there just fits into a 3/16 inch shank hole. That's the AN5 rivet squeezer die. You just drop the ram down in here. I've got to bolt it all together though. It's obviously not finished. You drop the ram down in here and hit it with a couple of decent whacks with a 4-pound sledge. 3 to 4 whacks with a 4-pound sledge, and it's going to set that rivet exactly where it needs to be. So I have no doubt this is going to work. It absolutely is going to work. There's going to be no problems with it. Very little technique to learn. You just got to make sure everything's squared up and centered properly before you roll with it. But that's basically it. It's a very simple machine. You can actually make these out of wood, but I think I've only got $25 in materials wrapped up into this one, and it's basically going to become a permanent fixture in my shop. I'll be able to do any kind of solid riveting I want to with this thing. Just a couple things I might have to do yet is put some bushings on the top here to eliminate any of the play in the ram, but it should do fairly well as it is. There's a little bit of flex in my drill press table, which, you know, I can't, this really thick stuff is hard to drill, so there's a little bit of slop in the hole, just a tiny little bit that I may have to just take up with a nylon bushing, but that'll be that. So I'm hoping to get that done today, and, you know, run some test rivets on the bending brake, make sure everything's all good, and I'll take it all apart, paint it, and it'll be a permanent tool for 25 bucks. Thing I should have done the very first time, not messing with the arbor press and not messing with the rivet gun. So I'm both frustrated but happy I've got the ability to do this. Moving on to welding projects. I borrowed this technique from Timothy Anerud's channel. He's also building a CH750. Friend of his came up with a way to use a piece of 1 inch by 1 inch by 1/8 inch angle with a outer diameter pipe of 1 inch. You weld these two things together, and then you can clamp this side down to the table, and what you can do is bend your flap-around skins around it manually, so you don't need a press brake or any fancy bending brakes. You just clamp that down to the table, bend your flap-around skins around it, and it gives you the proper diameter. For that, I just need to weld these together. Originally didn't have the welder, hadn't decided to start welding, so I was scratching my head on how to do this, but then once I got the welder, it dawned on me that, well, now I can weld whatever I want. So this makes it easy, and I don't have much wrapped up into this material either. I bought an extra piece of 2x2 tubing to cut in half and use for runners on the table for leveling purposes and things like that. But in the meantime, I might leave this at 8 foot length, as an 8 foot length, so that I can bend the flap around skins first and get those out of the way, and using this as a straight edge to bend over that radius here. So that's a little welding project there. I also picked up a handful of little squares and gussets and things like that to use in the welding projects. Back in my welding video, I talked about welding my first project up being a welding cart. So you can see here I've got the shelf frames tacked together. I've got some risers here to make the rest of the cart all cut to length and cleaned up. The welding is starting to come along. I probably got about an hour and a half worth of actual seat time under the hood doing some TIG welding, and had to resharpen my tungstens a lot, but that's actually getting better, and I'm starting to learn you know, how to weld and get a proper bead and how to do tacks and things like that. So I've still got many more months of work to come up, you know, to get this down right, but I've already made some progress in just the hour and a half time that I've had under the hood. So moving on, the Porter cable chop saw, one quick comment about that. This is a I believe a 14-inch diameter abrasive disc chop saw, and it cuts that real heavy material beautifully. That's a piece of the channel and tubing that I'm making that C-frame out of. This thing works fantastically. When I first tried to cut some of the thin wall tubing for the welding cart, it wasn't cutting square. I found out that was because I was either using too little pressure or too much pressure on the abrasive disc, and it was causing the blade to wander with too much or too little pressure. But if you get it just right, there's a little bit of a feel to it. When you get it just right, it cuts pretty much perfectly square and very evenly. And thick or thin material doesn't make any difference. It goes through all of it just fine. Thicker stuff just takes a long time, throws a lot more sparks, but worked great on that real heavy channel. So I was happy with that. Moving on to the Harbor Freight welding table. Not real thrilled with that welding table. It's a little warped. It doesn't, you can square up some things, but if you're welding like a frame like I was doing for the welding cart, not the best option. You can compensate for the warpage in the table itself with shims and things like that, but can't complain too much for the 50 bucks I paid for it. You know, it is what it is. It's a $50 welding table. Not the best, but it works. So we're good there. The grounding is no problem on it. It does what I need it to do. Back to the welder itself. In the previous video, I talked about the imported foot pedal here that a lot of people don't like. It's kind of backwards from a Miller or Lincoln style pedal where you can put your whole foot on the pedal and pump it like a gas pedal. This is backwards from that. My quick solution so that I wasn't pushing the pedal all around the floor when I was trying to operate it was just to bolt it to a piece of scrap wood here and put a little ridge on the back to set my heel on. It slides all around the floor whenever I want it to, But when I put my heel on that ridge and put the ball of my foot up here on the pedal, I can control the pedal perfectly without having my foot move around and sliding all over. So that was the solution to fix that. And then one last note, I had originally said in my welding video, my welding primer video, that I had about $1,300 wrapped up, including the cost of the tank, which I had yet to buy for all my welding gear. That was a bit of an error. Welding tanks were a little bit more money than I thought they were going to be. So I was originally planning on getting a 80 cubic foot tank, thinking I was going to spend about $150 for the tank, plus a little bit extra for the argon. Turns out an 80 cubic foot tank around here runs about $316 filled, and then the fill price on that is about $49. So once you empty the tank, it's another $49 to swap it out with a refill tank. So the tank itself was basically twice the price for an 80 cubic foot one. Well, this is not an 80 cubic foot tank. This is a 150 cubic foot tank. So an 80 cubic foot tank was around $317. This was $389. I thought it was a lot better of a deal per cubic foot to buy this bigger tank, and then the fills on this size tank are only like $60, $65. So your price per cubic foot of argon drops significantly the more you buy. And it's kind of the same with the tank. The larger the tank, the less you're paying per cubic foot of capacity than you are with a smaller tank. So it's possible to buy like a 40 cubic foot tank or a 20 cubic foot tank in the $150 range, but you don't get a lot of seat time on your welder with that. So I originally planned on the 80 cubic foot tank, sprung the extra $250 to go with the 150 cubic foot tank, and now I've got a lot of seat time I can have with this welder before I run out of argon. So just a few things I've learned and little updates on tooling here. So if you got any questions, please let me know. Thanks for watching and good luck with your projects.